Hey everyone, welcome back. Today we're going to talk about the factory method design pattern. So, what is the factory method design pattern, anyways? Well, it is another creational design pattern which provides us with a way for creating objects, but allowing the subclasses to determine the type of those objects. Why is it so good? What does that mean? It means we're going to lose the coupling of our application by heavily using inheritance to determine the type of objects we're going to create with the subclasses. So instead of using that beautiful new keyword we typically see, we're going to use a factory method to create our objects. It's useful when we don't know beforehand the types of objects we're going to use within our application. So by using inheritance, it provides us with the flexibility needed to extend our code. Remember the principles? So open for extension, close for modification. So, what are the elements and characteristics of the factory method design pattern? We typically have a creator class or interface. It typically is an abstract class or interface. What does it have? The method that we're going to use for creating the actual objects, which we're going to refer to as products. Since we have abstract or interface, it means that we're going to have a concrete version of them. So we're going to implement or extend that interface or abstract class. That is the actual implementation for the concrete creator of the determined product type. As we're talking about the product, we're going to have an abstract version of the product. So that means the representation of the type we want to create in the end. Since we have it abstract, we want to create a concrete version of the product as well. Let's make it more visual with the class diagram. So here on the right portion, you get to see we have the product interface, which are going to be used for representing the type of product we want to create. Here you get to see it has one method, so it means that we're going to implement that method. And down here we have the concrete versions of those products. So concrete product A and concrete product B as well, which determine different types of implementations for different products. On the left side, we have our creator methods or our creator classes with our creator methods inside, or the factory per se. So here on the left, we have the creator, which is our abstract class. It gets some properties if you need them. And note the first one here, it's a create product return, the create product method returning the product, which is abstract. Since it's abstract, we need to extend that class and implement the create product method. So we have a concrete creator A, which creates products of concrete product A. And then we have the concrete creator B, also extending from the creator, which creates concrete products of B. Let's see the code. So here in the IDE, you see that we have a factory method project. Let's expand and dive right in. First, let's navigate through the structure, which is going to resemble the diagram we've just seen. You can see that we have the concrete creators A and B, concrete products A and B, the abstract creator, and the interface product. Let's first run it and then we talk about the code. So when we go to our main method, first execute, you get to see that we have concrete product A is doing something, concrete product A is doing something. Since we just used the product A for now, for this example, well, we can expand on it. The first part just shows the typical object creation process, which we just instantiate based on the concrete class that we want to retrieve. Then we invoke the doStuff method from that class, which prints concrete product A doing something. The other one, using factory, you can see that we have a reference to the creator at this time, and we instantiate the subclasses. This is going to be the power of it. We're going to use the subclasses to determine the type of objects we're going to create. So now we create another reference for product A. And now from creator A, we're going to create a product. So you see, we're not instantiating the product class directly. We're using it through the factory. We're creating it through the factory. And then from the product we've just created, we just call the doStuff method, which prints, well, the exact stuff. So here we have the product interface, which is just used for representing the type of object we're going to create in the end. So from this interface, it means that we're going to implement it. So from concrete products A and B, we define the behavior for those concrete classes. So you can see that concrete product A implements the do stuff method in a certain way, which is the way we've seen before. Now we want to talk about the concrete product B, which is the exact same type of code, except with a different type of implementation. So we do have two types of products. For creating our product, we are going to have the concrete creator A. We're going to talk about the extends creator in a bit, which is the factory method for creating instances of concrete product A. Similarly, concrete creator B has the same type of method, which is the create product for type B. We're making sure that since this is an abstract class, it's going to be implemented by the different types of creators if we have different types of products. And here we have the abstract method that is going to be implemented by the children, returning each type of product. What is the benefit of it? I don't have to change my code if I create a new type of product. Of course, I need to extend certain classes. I need to implement certain classes, but I don't have to change what's existent in my code structure so far. So let's say we create a new type of product, let's say product C. So here we have concrete product B. Right click, new, this class. We're going to create a concrete product C. Once we create this product, we already have base class or base interface that determines the behaviors that our products are going to have. As soon as I implement that interface, we need to implement the abstract methods. So we have to provide an implementation. Let's erase this. For now, we're going to create system out. So concrete product C, doing nothing, let's say. Let's save this. That's perfect. But I don't want to just instantiate concrete type C from here, right? So product C, new concrete product C. I don't want to do that. I don't want to expose that. What I want instead is creating a factory for those types of products. So new concrete creator C, which we don't have yet. So we have to implement that factory. Remember, we have the creator. So what do? I'll click here just to let the IDE help me. Create a concrete creator C. It'll put it right there. And you can see that it already extends creator from the type that I typed. I'm going to delete this for now. Why is it complaining? Because we have the abstract method. So if I click implement the abstract method, now we have a create product method since we're implementing the abstract method. Let's delete this. Notice that we're returning a product. So I will return a new instance of the concrete product C. Did I have to change products A, product B? Not really. Comparing to the simple factory idiom, where I would have to go back to my code and modify it to add another else condition. So back to the main method, concrete creator C. Now I will create product C equals to receiving from my creator C. I will create my product. And then my product C has the object I want to invoke. So if I run this now, concrete product C is doing nothing. Now, let's take a look at another example, the restaurant factory. So we do have a restaurant that provides us with some type of burger, well, that we can order some type of burgers. So we're going to create objects that are burgers. So let's expand this. You can see that we have a bunch of code here. Let's take a look at the diagram first. So what is the structure here? Looks like the exact same structure. So we're going to have a creator class, and we're going to have an interface product to represent the product, which in our case is going to be the burger. You have different types of burgers. So which type of burgers do we want? Here we're going to have the beef burger and the veggie burger. Our creator is going to be the restaurant responsible for creating our burger or producing our burger. It's generic because you have different types of burgers, right? So you have to implement different types of concrete creators or different types of restaurants. So here you have the concrete creator A, which in our case is going to be the beef burger, and the concrete creator B, which is going to be the veggie burger. So if we go to our main method, we can see the structure is quite similar. So at the top here, we have a restaurant reference, and we instantiate beef burger restaurant. Okay, so we instantiate the actual child. And then from that reference, we call order burger. If you want a different type of burger, the veggie burger, we're going to instantiate the veggie burger restaurant. And of course, you're going to invoke the method or any other operations you want. So let's take a look at the products first, similarly. So our burger is going to represent the type of product or the type of object we're going to create. We're interested in actually creating. This is the generic version of it, or the abstract version of it. So we want to create concrete versions. So from the burger, I want the beef and the veggie burgers. Let's go to beef burger. So beef burger derives from the burger. We're just creating a method, we're just printing, preparing that burger. Similarly, the veggie burger also implements our burger, and the prepare method has to be implemented. So we just provide with an implementation. Perfect. So we do have the right side from the diagram, if you remember. Now we're going to create the actual factory method. So if let's start with the abstract version of it. So here we have an abstract class restaurant. But we do have a concrete method. So far so good, because we still have our factory method right here, which is made abstract. That means children have to implement that abstract method. Public void order create order burger. So what is this method doing? This method is ordering the burger, and it's just invoking create burger method, which comes from down here. Since this is abstract, this is going to be determined by the children. See how powerful it is? Creates the burger, determined by the concrete children, assigns it to the burger reference, and invoke any operations you want from it. So let's go to the beef burger first. Beef burger extends from our abstract restaurant, and the concrete version of it. This is just printing, but we're interested in creating the actual concrete product, which is our beef burger. What do you think the veggie burger is going to look like? If we go to the veggie burger restaurant, same idea. So here we have a public method that returns a burger named create burger coming from the abstract restaurant, and we return a veggie burger. What if we want to create the chicken burger? New class, I will create the chicken burger. First, I will implement from my burger. Now I have to implement my abstract methods, which is the prepare. This is out. Preparing chicken burger. Okay, I created my product. Now I have to create my factory. You guessed it right. So new class. This is going to be my chicken burger creator. What is the structure? We have restaurant, right? So let's use the same one. Restaurant. This extends from our restaurant. We implement all the methods. Create a burger. Let's use the same structure. So this was preparing chicken burger, and we return a new instance of our chicken burger, which is our concrete product. So now we have the factory and we have the concrete product as well. So from our main method, didn't have to touch existing code. So restaurant, chicken, resto, we instantiate the children and the concrete version of it from the chicken resto. I will order the burger. Let's run, see if it works. And there you go. Ordering burger, beef, prepare the beef. Ordering burger, veggie, prepare veggie. Burger, creating chicken, preparing chicken. Looks nice. So again, helps us with open closed principle. We didn't have to change any of the concrete classes or the actual abstract classes. So if we prepare all those classes and interfaces in advance, it makes our code a little bit more extensible. So what are the key points for factory method design pattern? First one is the actual factory method, which we put the responsibility for creating objects into that factory method. It leads to the decentralization of the creation process, since each creation process is separate into different classes. By doing that, it helps us with the extensibility of our code. Remember, we just create new types. We don't have to modify what's existent. So this was factory method design pattern. I hope you enjoyed it. Let me know if you have any questions in the comment section down below. Hit the like button and subscribe to the channel for new videos. I'll see you in the next one.